All right, so today I did not make any slides, and so I decided I would just write the intro slide as text on the screen. And so we have 40 minutes without any slides. So we're going to be looking at code and writing some code, and hopefully it's going to work. But it is really hard to speak and think about what you're doing at the same time. So it's very likely that I'm going to make mistakes. So I'm going to be the keyboard, and I might need you to be the brains and tell me what I did wrong if that happens. So I'm counting on you all to tell me if something's wrong with what I'm doing, because it's likely that, well, hopefully not, but demo effect and all that. Okay, so today we're going to talk about the title of this talk is Root Causing Memory Growth with LeakCanary 3, and so we're going to talk about memory growth, which is not exactly the same thing as memory leaks. So just kind of like, who's somewhat familiar with LeakCanary, heard of LeakCanary before? Okay, most folks in the room, that's great. So we're not going to talk about LeakCanary much today. But what I want to do, I'm going to zoom out. Okay, reset to 100%. And I have a running device here. And what I did is I just loaded there's a Jet News app that open source by Google, and I just loaded that, and I'm just going to be running it. I'm hoping that we're not going to run into build failures or Wi-Fi. It was working just before, but you never know with these things what might happen. Like, why is it taking a little bit of time? Anyway, so we have this Jet News app. I don't know if you've checked it out. It's a Compose example app, and yeah, and that's what it is. So they made this app, and you can navigate around and look at a bunch of Compose talks, content, I guess. And so what I was thinking about this, I was like, oh, it'd be nice to have analytics in that application, like to know that, to log somewhere, like what happens when we're navigating. So let's imagine that we are going to create a new Kotlin class, which we're going to call, Jet News Analytics. And sure, add it to Git, who cares? And so it's gonna take a nav controller, because we need to know about navigation with a nav controller, and in its init, it's gonna say, okay, nav controller, I'm interested in knowing about destination changes, right? So we're gonna do this, and I think I have, where do you get a nav controller and let's see what's in there. Okay. So we have 3 arguments to this method. So we're going to go back here, and I guess I'm not really good at this, so we're just going to copy this thing and cut it off and put commas. There's probably a better way to do this, but this is what we got. Okay, so we got our 3 parameters, and so whenever there's a new destination, what we want to do is log it somewhere. And so to do that, I'm going to create a class navlog, and maybe it's going to take a root, but there's not always a root. And then a metadata is going to be, we're going to call that like matrix, and it's going to be a list of long, because we're like, oh, we want our matrix to be a list of long. And so we're going to have these navlogs, and they're going to be vals, right? But metrics, we're like, I don't trust whoever is passing me these metrics, so I'm going to make a defensive copy of those. So I'm going to do like a val metrics equals, and then I'm going to do a linked list, because I heard linked list is cool. And so I'm going to turn that into a linked list. So we have our navlog, and basically every time we navigate, we're going to keep a list of navlogs. And we're going to say it's a mutable list of, this time I'm not using a linked list, because I don't know, I have no good reason to use one maybe. And it's going to be a list of navlog, right? And so every time I navigate, I'm going to add a log to the navlog. So I'm going to do, add navlog. I'm going to pass in the destination root and my matrix. And so for now, let's pretend that it turns out that matrix is actually an array of long, with about 100,000 ints in it. And so because I decided I wanted a list, but this is an array, I guess I'm going to just do 2 lists, right? And maybe I didn't pay close attention. I thought I was using a defensive copy. It's safer, and a linked list means it's exactly the right size. I don't have an array that's bigger than it needs to be, whatever. But this is what I got right now. So I have a Jet News Analytics, and the next thing I'm going to do is start using it, right? So simply here, I'm going to say, hey, remember, and because we're tied to the nav controller instance, so nav controller, and we're going to say Jet News Analytics, right? And this needs the nav controller. And that's it. And so now if I run the app, nothing has changed. So as you know here, I'm just shoving analytics in this nav logs list. And then eventually I would want to maybe send that somewhere or do something with it. But for now, let's just say that I'm keeping all the analytics in there because it's time to go home and I haven't had time to do the rest of it. And I'm leaving this code as is. So what happens when I navigate? Well, as I navigate, we're adding more navlog entries to this thing. So then, is this a problem? Did I make a giant mistake doing this, or is this fine? Who thinks this is fine? Yes, Jesse thinks this is fine. It's probably fine. Who thinks this is a problem? Yeah, I see a couple hands like no people, and a lot of you are like, I don't know what the right answer is, so I don't want to raise my hand because it's okay. So let's see what happens if you try to do that a lot, navigate a lot. So let's look. I think I saw some Jet News tests here. We're gonna just copy one of these tests, whatever that is. Need a method name. Baguette sounds good. And so, well, what I'm gonna do is I'm gonna try to just navigate around, like go from here to here and then go back here, right? So I'm just doing that repeatedly. So I'm gonna repeat 100 times, navigate around. And so I guess I'm just gonna copy this, which navigates to the interest screen. And then I think there is this checks that we're on the home screen. So we're gonna navigate away. I think we have to do this navigate on home. Maybe, and also I guess do the same thing. Open the, I made a mistake. It's not hook, it's home. All right, so open the drawer, go to interest, make sure you're on the right page, then do home, right? So I'm going to run this, which, okay. Okay, so I'm running this. And hopefully, at the same time, I want to look at what's happening with the memory side of things. So let's see if I can get my thing running. Give me a sec. All right. So here, this is starting to run. So you can see we're navigating back and forth here, and let's look at the memory. So what's happening as we are navigating back and forth? If I put my mouse here, you can see that the Java memory is growing quite a bit, significantly over time. So what will happen eventually is we're gonna, end of the test. Did we reach 100 iterations? Probably not. Yes, or we got this, which it's to start Chrome. So where is my Chrome? Oh, I guess I didn't mean to start Chrome, but I guess I did. So there we are. Yeah, out of memory error, not enough memory in my device. So. Well, that was easy in a way, right? We just wrote a test that ran the script, and we found that we were doing something bad. Now, what if I had done, just 10 entries in that array? Then if I did that, and we ran the test again, which I'm going to do right now, we're probably going to go through 100 iterations, and the test will be successful, because the memory this time is not going to grow as significantly. And so let's just see if we can see it again. Here. So you just see memory going up and down, and it's because we're talking about hundreds of megabytes of memory, and then this is like 10 ints at a time being added. it's not too much. And so we are probably going to reach 100 iterations without a hitch. But you've seen how, as we accumulate things, we eventually run out of memory. And the thing is, with a smaller, smaller size array, we will also run out of memory. It's just going to happen in a longer time. And so that's a problem. But we're not able to detect it. Hopefully, the test passed this time. Yes, successful. Woo! So we have a problem. We're not able to detect this memory leak. And one thing that we know that we found from production data, I wrote a blog post about that, but this is a graph that shows the blue line is the memory size, the usage of the Java heap. The red line is the max. And the yellow is the performance of the app, how long it takes to navigate around. And so you can see that as the blue line gets close to the red line, you don't get an out-of-memory error immediately. First, what you get is a lot more GC. And because you get a lot more GC, that navigation latency just spikes. And so from a user point of view, before you get a crash, you actually get slowness of the app, a lot of jank and freezes. So we want to fix these things. So what would we normally do when we hear, oh, we might have a memory leak? Like, what do? We bring in LeakCanary, right? Woo! So let's do that. Debug implementation, square up. Ooh, can I write? No, I can't type. I also have to say my A key on this new Mac M3 MacBook Pro. The A key is already kind of broken, so that's not great. Square up LeakCanary. Let me just take the version number on my thing here. It's on my tray. LeakCanary Android, and then we're going to do 3.0-alpha-8. And hopefully it's going to work. Hope I got this right. So as you know, normally what you do is you just add LeakCanary, and then you don't change any code, and you just run the app, and you wait for LeakCanary to tell you that something is wrong. Which is what we're going to do right now. So I'm here. I'm going to navigate a bunch. Well, we could wait, but we're not seeing any notification. So LeakCanary is not finding anything here. We clearly made a big mistake. We're clearly using memory, but LeakCanary is not finding anything. And so, in a way, for these kind of problems, LeakCanary is not useful. It's kind of useless. That's unfortunate. Don't know why I made this thing. All right, so why does it not find things? Well, the way that LeakCanary works is that it knows about specific objects like activities, views, fragments, and they have a life cycle. And when that life cycle is reached, when they reach their end, that gets passed to their instance is passed to LeakCanary, which keeps a weak reference to them and uses that weak reference to check if the object is garbage collected or not. And then if the object is not garbage collected, that's when LeakCanary will do a heap dump, a copy of the memory to a file, essentially, and then parse that and then find the object. And then find why it's still retained in memory. That's what the leak trace shows you. The problem here is that with our JetNews analytics, there's no activity, there's no view, there's nothing in that list, in that nav log list. It's just a bunch of primitive data, and it's just too much of it, right? And so LeakCanary has no idea, no way at runtime to detect that. So what are we going to do about that? And also, even if it could, find big chunks of data, it's really, sometimes it's okay. Like sometimes you want to have a big chunk of data somewhere if you're kind of in control. So what could we do? Well, we could try to maybe count the number of objects that are in memory. And one of the ways we could do that, and this gets kind of interesting. So if you watch, I hope you watched Jesse's talk this morning, but if you didn't, here he talked about how this is Jesse's here, but this is him speaking. He talked about how logical memory is a big graph, and every object is some values and then some references to other objects. And so at runtime in Java, in Kotlin, we are manipulating the graph, but with a heap dump, we can also read that graph and navigate it. And so we're going to try to do that right now. So let's see if I can get that done fairly quickly. So let's say that we're going to run the scenario twice, and we're going to do a heap dump at the end of each run, and then we're going to compare the results. So if we did like 2 heap dumps, and we're going to say, okay, my heap dumps are well, I'm just going to have 2 runs. I'm going to do 1 to 2, and I'm going to map into that into something that's going to capture the heap dump, right? So I'm going to get my heap dumps. How do I do that? Well, there's a Android method called debug.dump hprof data. And so you just need a file. So one way we could do this is we're going to say, okay, well, file.create temp file, and then we're going to say heap as a prefix, and then maybe hprof .hprof as a suffix, and then we're going to say what do you apply? Apply is good, yeah. And then we're going to pass in the absolute path of that file to dump the data in. All right, so this will run the scenario twice, and each time we'll dump that into a file. And then we need to parse that. And LeakCanary comes with an API for that. So you can actually absolutely do that today. So let's see if we can map that again. And this time we're going to say, okay, it.openHeapGraph. So on file, you have an API called openHeapGraph. You have to remember to close it afterwards. So we're going to call use to make sure it's closed at the end. We're going to get a graph. And let's say that I want to do get the object count. Oops. So graph dot. So this will tell me how many objects I have in memory. And so that's going to take me like, okay, val counts. So now I get 2. I did 2 runs, so I get 2 entries in this, and it's the object counts for each of the heap dumps, the 2 heap dumps that I did. So I guess I could do assert equals, and then we're going to do counts of the first entry and counts of the second entry. And so the idea with this test that we're trying to write is we're saying, hey, let me see if I can run it. We're saying, hey, you know what? We did a thing. We came back. We did the same thing. Hopefully, we should be at the exact same. The memory should be the same because we just went back and did the same thing. So hopefully, we're not saying a difference. And the test fails because obviously there is a difference, and it's telling us, hey, there was, the first run had, or I guess yes, the first run had 570, 100,000 objects, and then it's 644. So it's quite a few more objects, not just like the couple longs that I added, but a lot more objects. And one of the reasons for that is well, let's get back to what Jesse was saying. One of the reasons for that is garbage collection. Objects are created all the time, but they're not destroyed immediately in a JVM. And so when the GC runs, it will collect objects that are not referenced, but when we take a heap dump, you get all objects that are still in memory, whether or not they are still reachable. So, and what can we do about that? So one thing that I wanted to try, I don't know if we're going to have time for this, but it felt like something fun we could try, is what if we did the same thing that a GC is doing, but in code, and we try to find only the objects that, that exist in memory at this point in time. And so to do that, we're going to be doing a software engineering interview. We're going to do a graph traversal. I hope you're ready, and I hope it works, because it is not easy to do that, but we'll get there. I mean, it's actually not that hard, but let's see if I remember this right. So the first thing we do is we need a place to start, and that's the GC roots. So GC roots, they're like static fields in a class or local variables. So we're going to have our GC roots. And we're going to have a queue of things that needs to be traversed, and so we're going to have that as an array list is fine, mutable, and because we want to be cheap on memory, we're going to say we're just going to keep the object IDs, and so that's going to be. See, my A key is not working. That's going to be our queue. So the first thing we want to do once we have a queue, I guess I could just do it without doing a local var, is I'm going to add all the things from this, and I'm going to map the object ID, right? So every GC root has an ID, and so I'm adding all of the GC root IDs to the queue, and then we're just going to traverse empty the queue, essentially. And traversing is just taking an entry from the queue, finding if there's more stuff, putting that new stuff back in the queue, then taking the next entry into the queue. So for that, we also need a set of things we've visited before, so that we don't keep visiting the same stuff, because the graph sort of like circles on itself. So mutable set of long. All right, so we have the things we're visiting, and what we're doing next is we're going to remove the first entry. Or I guess we could call that node, whatever we want to call it. See, I can't type. Removing the first entry, and then if we've never seen that before, so if node.objectId, it's an int. So if it's not in the visited list, then we're gonna explore it. And exploring it means simply we need a thing to expand the edges of a node, right? And that's maybe the tricky part. But in LeakCanary, you have I recently made public some classes that will help with that. So you need an Android, reference reader factory, very Java. And it's going to take an Android reference matchers.default. And so that's our factory. We can move that out. And then here, you're going to say, OK, I have a graph. I'm going to create for this graph a reader. OK, so this is a thing that knows how to expand references. And so once we're here, we say, hey, so the first thing we want to do is we want to go from the ID, which is a long. And so we say, hey, graph, find this object. All right, and so this wasn't really node. This was more like object ID. And this is going to be node, I guess. So we say, OK, find me the node. And then, hey, reader, read me this node, right? And this returns me a sequence of references. And so all I got to do, if I remember right, is just do so q.addAll, and then we're going to do this returns a sequence of references, and we just need to map that to the object ID. And it's a sequence, so we want a list instead. All right. And so with this, instead of counts, what we're going to return now is the visited set, which is a set of long. All right. And yeah, I think. Oh, actually, let's do more than that. Let's make that a set of long and string, and that way, when we add, and we need to add to visited here. Hey, otherwise we're going to keep visiting the same thing. So we're going to add the object ID, and then just node.toString. Sorry, what am I doing? It's a set that doesn't exist. Let's do a set of a map. Yes, mutable map of. Yeah, thank you. Okay. Yeah. Okay. So we have a map, and we're going to pass it a pair of node.toString. Okay. So we have this. We've returned visited, and so this is now. So if there's no need for an else. Here we're just already visited. Nothing to do. All right, so if we find the same object again, we just say, oh, I don't care. Yes?
Your if gotta be contains key or something.
What did I do?
In your if, line 115.
115.
You gotta do like contains key.
Isn't that what this is? Yeah. Yeah, the magic of Kotlin. Not in is contains key.
I thought it was contains line.
Yeah, no, yeah. It's a good point, but yeah. In this case, I'm lucky it works. All right, so if we did, so we expect the sizes to be the same. So we could say assert equals, size, size. But we could also do, okay, well, I'm going to remove, how do you say, delete or something? Is there a way? What's that? This is, I'm trying to, oh yeah, no, I need to get the first entry. It's not visited.size, sorry. It's first entry versus second. All right. All right, so we have this, and then I think there is a remove, but I don't want to remove all. I want to, delete, no. There's a way, I'm trying to find, to say, actually I want to go from the first one, and remove the entries that are in the second one. So remove all. I thought removal was keys removal. Does that work? Is keys a writable? It's a mutable set, I guess. So, okay. Keys dot remove all, and then visit one dot keys. Yes, zeros. Thank you, my dear debuggers. So this and this removes. It updates visited one, right? So then I can do for each, and we're just going to print it to lockat. And then it's dot the second, right? Is it? It's a map, so it's value. All right. I guess we could do it dot value and it dot key. Okay. So that's just to see what we're finding.
Drop the assert equals above.
Yeah. Right. Yes. Well. Let me just first, because so just this point is the test is going to fail on the assert equal, so we're not going to get to that. But I just wanted to get the size before I change the size of the array. So what's the point of this? Let's run this and then talk through it a bit. So the idea here is, the memory is a graph, and we are operating on that graph, and what we're actually doing here is very similar to what the GC is doing, except what would happen with the GC is it would traverse the graph in exactly this way, but it would take visited, and then it would take the list of all objects, and it would say any object that is not in the visited set is unreachable and can be removed from memory. So this is effectively, it's a after the fact, post-death garbage collection. It's corpse disposal. I don't know. Anyway, so let's see. This is running. So of course, doing a heap dump takes a little bit of time, but hopefully this is running. And if we didn't mess up something, so we're gonna see. What are we seeing? Failing test. So first of all, the numbers are a lot closer. So it was garbage collection that was inflating those numbers. And you can see there's about 33 more objects in memory. But the other thing though is if we do adb lopcat grep baguettes, there's a lot more than 33 objects listed in there. And so the reason for that is the object ID really just maps to the address in memory of an object. And in an Android VM, the objects move around all the time. So basically, as the GC is passing and doing work, it takes some stuff and moves it from one zone to another zone. And so what you see is that between two heap dumps, the IDs of the same object, the same instance, is not consistent. So we don't have an easy way to say, and so this is a problem here because it doesn't help us identify which are the new objects. And even if it did, it's not ideal because sometimes you do want to be creating new objects. For example, an array list that's growing will create a new backing array, but it's the same array list. And so it's not necessarily a problem. So, oops, sorry. So I want to get to maybe so I was kind of stuck at that level and what can we do about this? How do I find where I'm growing? And reading the Android Studio code, I stumbled upon this paper here, which is I don't know who likes to read papers on their spare time. I don't. You don't have to like that. But anyway, it's called Bleak Automatically Debugging Memory Leaks in Web Applications, and it was a research paper, and they implemented this for Gmail. And essentially, it's very similar to what we're doing here, was this idea of running a scenario in a loop and doing heap dumps and trying to identify if the memory is growing. But the key finding that they had, which I'm not asking you to understand this thing, it's a little bit I have a hard time reading these papers. But the key finding that they had was that instead of focusing on specific object instances, something that is a lot more stable is the structure of the graph. The fact that there are nodes that have references to other nodes. And just if you forget about the name of things and look at this and the specific object ID, if you look at the structure of the graph, it's mostly stable. And then what you can do is look for the nodes that have an increasing number of edges over time. And so that's the key finding that they had in this paper. And so the idea is, in our case, like an example of that is our analytics, right? If you think about what if the list is a node, it's got an increasing number of navigation logs added to it, so an increasing number of edges to other objects. And so they implemented that in JavaScript. I tried to read the code and couldn't get most of it. But I sort of figured out what they were trying to do. And I implemented, I guess, my own version of that in LeakCanary. And so that's what we're going to be using now. So we're going to keep most of this fairly similar. But instead, so I need to go to the build.gradle and add a new dependency. It's going to be test implementation. And it's going to be, I think the name of the artifact is Android test, LeakCanary Android test. And for reasons that I'm not going to go into right now, I need both of this. That's specific to the Jet News project because they like to run the same test in Robo Electric and in the Android VM, which is kind of interesting. Anyway, so we're here and trying to remember the key classes. Yeah, so there's a new class now called heap.diff, and it's giving you a helper method that's going to help, that's going to give you, we're going to call that maybe a detector. And that's the thing that's going to be running these loops that we just been. We did it manually ourselves, but here we're going to have something that does it for us. And so the detector has this method called find repeatedly growing objects. And we need to decide how many heap dumps we want to do at most. So we're going to say 5, and we need to decide in between heap dumps, do we want to repeat the scenarios multiple times? So I'm going to say 10 times just to make sure. So like the idea is we don't have to do a heap dump every time we do a scenario. We can do a couple of them. If I do 10 scenarios, then I'm only interested in nodes that grow 10 times. Because the idea is to find growth specific to running a scenario once. And so here I'm going to do that and then just go do the scenario. And I'm going to remove this part and remove all of this. So now I've got this, and we're just going to assert, and so this returns something we're going to call, what do we call that? A diff, I guess. And then we're going to say assert equals, yeah, and so we want, what did I do? No. Oh yeah, because this is not, okay, this is an empty list. We want to make sure that this is an empty list. And so the growing object. So, and I think we need to provide the type of growing object nodes. So this diffs has the list of objects that are, or nodes that are growing. And we just want to assert that it's an equivalent to an empty list, meaning there are no growing nodes. And so we're going to run this again. And here, so that's the idea. So you can see it's running it 10 times. Then it should be doing a heap dump. And that's why it's not moving. And it should be doing that 5 times. It should take about a minute. So we can have silent time and meditate a bit if you want. You'll call or look at this beautiful, quickly animating screen. So that's the general idea, and we'll look at what it ends up being. But so this is max heap dumps because the idea is if after 2 heap dumps we find that nodes haven't been growing, we just stop there. So it's really repeatedly growing nodes that we're interested in, meaning not just some random object that gets added and then deleted, but for a specific scenario. Do we find a case where every single time that we do the scenario, we see something growing, which should be the case here. The reason we're repeating it so much is because there's going to be a lot of random stuff happening, and this is sort of a way to avoid the random stuff that happens, class loading, runtime object, whatever. So let me see, we should have a better view with this. So this is what we end up with. So this part is a normal stack trace, you know, in your test, fail, and then this is just a this is just a message, and so it's saying, you know, hey, I expected an empty list, but I got this thing. What is that? So it just so happens that the element in that list implement a toString that is a little bit similar to LeakCanary leak traces. It's showing you, okay, this object is it's not that this object is leaking, but it's that this object is growing. Like this field called navlog is growing, and we can see that the retain size was increased by 4 kilobytes on the last iteration, and that was running 10 times the scenario, and then the number of retained objects as well. And so this is essentially, and this is a leak trace that helps us understand, you know, oh, what's holding on to Jet News Analytics? Well, it's the slot table from Compose, because that's where we put it. But with that, you get something that looks similar to LeakCanary and then points to an object in memory that has an increasing number of edges to the rest of the world. So a while ago, when I tested this, I needed an app. I've talked about this before, but I needed an app to test this out, so I figured, you know, let's take Slack. And so I downloaded the Slack app, and I wrote a blog article about that. I don't have access to the Slack debug APK, and so I had to jump through a bunch of hoops to actually be able to do this. But essentially, and this is what the blog, you know, goes on about. It's like how I did that and all that. But I ended up writing this test that just like switches back and forth between the two workspaces, and ended up finding, you know, a couple issues that I shared with the team, including, I think, and that's already fixed, by the way, but like there was one thread, the number of threads was increasing, which I realized after the fact there are other ways to find that. You can actually run some Linux commands to get the list of threads running, but, you know, I didn't know what to look for, and then I found this thread, and so this is what the blog goes on about. And with that, that's pretty much the end of the talk. So yeah, I hope it wasn't too much code. Yeah.